Hello, good people. Today we would like to discuss about number theory. It is about Fibonacci numbers. But before we start, let's get to know each other first.
Hello, so this group is consists of two girls, which is me, Balkis Parmeswari.
And I'm Nikada Ayu Indah Mahandari. So what we are going to discuss in Fibonacci numbers, it is the definition of Fibonacci numbers. The second is the history of Fibonacci numbers. Next, Fibonacci sequence. And we're also going to discuss about inductive proof of Fibonacci numbers. And the last one is Fibonacci numbers and plants Phyllotaxis.
So here is the definition of Fibonacci number. In mathematics, the Fibonacci number, commonly denoted as Vn, form a sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones starting from 0 and 1. That is, f0 equals to 0, f1 equals to 1, and fn equals to fn minus 1 plus fn minus 2 for n greater than 1. The beginning of the sequence is thus 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. In some older books, the value of f0 equals to 0 is omitted, so that the sequence starts with f1 equals to f2 equals to 1, and the rearrange is fn equals to fn minus 1 plus fn minus 2 is valid for n greater than 2.
So next we're going to talk about the history of Fibonacci number. Leonardo Pisano Bigolo, also known as Leonardo of Pisa, Leonardo Pisano, Leonardo Bonacci, and Leonardo Fibonacci, or most commonly simply Fibonacci, was an Italian mathematician considered by some the most talented Western mathematician of the Middle Ages. Fibonacci is best known to the modern world for the spreading of the Hindu-Arabic numeral system in Europe, primarily through the publication in 1202 of his Liber ABC, Books of Calculation, and for a number sequence named the Fibonacci numbers after him, which is he did not discover but used as an example in the Liber ABC. Next. Leonardo Fibonacci was born around 1170 to Guglielmo Binosi as a wealthy Italian merchant. Guglielmo directed a trading post in Bugia, a report as of Algiers in the Almohad dynasties, sold in North Africa, now Bejaia, Algeria. As a young boy, Leonardo traveled with him to Half. It was there he learned about the Hindu-Arabic numeral system. Recognizing that arithmetic with Hindu-Arabic numeral is simpler and more efficient than with Roman numeral, Fibonacci traveled throughout the Mediterranean world to study under the leading Arab mathematician of the time. Leonardo returned from his travel around 1200, and in 1202, at age 32, he published what he had learned in Liber ABC, books of abacus or books of calculation, and the Terebi popularized Hindu-Arabic number in Europe. Next. So next we are going to discuss about Fibonacci sequence. The Fibonacci sequence F1, F2, F3, and so on is defined by F1 is equal to 1, F2 is equal to 2, and Fn is equal to Fn minus 1 plus Fn minus 2 for n is greater than equal to 3. The recursive formula is easy to use if we want to list Fibonacci numbers starting with the beginning of the sequence. However, if we want to find the 1000 Fibonacci number F1000, then this recursive formula might not be useful. To find F1000, we will first have to find F998 and F999. And to find those, we will first need to find the term in sequence that come before them, and so on. All the way back to F1 and F2 to find F1000 using the recursive formula, we will thus have to find all of the Fibonacci number starting from F1 to F1000. So, there is also an explicit formula for the Fibonacci sequence known as Binet formula. This explicit formula also the number of n Fibonacci number Fn to be found as a function of n without the need to calculate any other number in the Fibonacci sequence. That is, Fn is equal to 1 over the square root of 5 times 1 plus the square root of 5 over 2 to the power of n minus 1 minus the square root of 5 over 2 to the power of n. The explicit formula is great for calculating any Fibonacci number without the need to calculate any others. However, this explicit formula lacks of the simplicity of the recursive formula and thus may be harder to remember. The recursive formula definition also has the benefit that since it relates each Fibonacci number to the immediately preceding ones, it is useful in inductive rule. So, this is the inductive rule. The sum of the first 5 Fibonacci number is 1 plus 1 plus 2 plus 3 plus 5, it's equal to 12, which is 1 less than the 7 Fibonacci number, that is F7 is equal to 13. The sum of the first 6 Fibonacci number is 1 plus 1 plus 2 plus 3 plus 5 plus 8 is equal to 20, which is 1 less than the 8th Fibonacci number, Fh is equal to 21. So at this point, we might conjecture that in general, the sum of the first n Fibonacci number is given by F1 plus F2 plus F until Fn is equal to Fn plus 2 minus 1. Next. To know that this pattern is always whole, we use induction to prove that. Prove that for every natural number n, f1 plus f2 and plus until fn is equal to fn plus 2 minus 1. To show that f1 is equal to f3 minus 1, so f1 is equal to 1 and f3 equal to 2, since that 1 is equal to 2 minus 1. Is it true that f1 is equal to f3 minus 1? So for p1, is true. Next to the inductive step, let k element of natural number n. Assume that inductive hypothesis Pk is P if f1 plus f2 until fk is equal to fk plus 2 minus 1. To show that f1 plus until fk plus 1 is equal to fk plus 1 plus 2 minus 1. That is f1 plus fk plus 1 is equal to fk plus 3 minus 1. Next. So we need to add fk plus 1 to both sides. Next. f1 plus until fk plus 1 is equal to fk plus 2 minus 1 plus fk plus 1. So it's equal to fk plus 1 plus fk plus 2 minus 1. So from the definition of the Fibonacci sequence, fk plus 3 equal to fk plus 1 plus fk plus 2. Thus we have f1 plus fk plus 1 is equal to fk plus 3 minus 1. So from here we can conclude that for every n element n that is natural number is f1 plus f2 plus f3 until fn is equal to fn plus 2 minus 1.
So here is about Fibonacci number and plants Phyllotaxis. Phyllotaxis is the regular arrangement of leaves or flowers around a plant stem. Is an example of developmental pattern formation and organogenesis. It clearly visible in the spiral patterns in the leaves, petals, buds, fruits, and or florets. Phyllotaxis is characterized by the different angles between the organs. The most common angle being is 137.500, or we usually know is as the golden angle. And for example, the buttercups have 5 petals, lilies and iris have 3 petals, some delphiniums have 8, corn and marigolds have 13 petals, some asters have 21, whereas daisies can be found with 34, 55, or even 89 petals. These plants have spirals in both directions around the stalk or body, and the number of spirals in each direction are 2 consecutive Fibonacci numbers. And so here is the picture, and the first is daisy flowers, and the second is the picture of ordinary cauliflower, and you can look at this almost a pentagon outline. If you're looking carefully, you can see a center point where the florets are the smallest. And if you look again, you will see the florets are organized in spirals around the center in both directions, which is the blue and the red one. And here we have sunflower leaves. As we can view from the top shows the same patterns. It is the same plant whose side view is above, and we see starting from the mark of X. And we can find that the next flower leaf turning clockwise, and the numbering the leaves produce the pattern shown here on the right. And the clockwise turn exactly 222.500 from the previous one. from x to 1, then turn to 3, and so on until 16. So that's from the plant's Phyllotaxis, and there is the research that we use for this presentation.
So yeah, that is our presentation and discussion for today's in number theory. Thank you for your attention and see you in the next discussion. Bye bye.
Bye bye, see you.